Actually, record. All right, so 6.4, we want to do surface areas with revolution, okay? And so we did volumes with this. We're just going to make some slight adjustments to it, and you'll see now why in the middle of these areas and volumes we did the length of something right then. So if we look at this picture right here, what we're going to try and do is take that little blue ring right there and figure out its area. And essentially, if we take the limit that Q gets closer and closer to P, right, that our little step is closer and closer, Q gets to P, we essentially end up with just like a ring, right? And what we need to do is look at this ring and say, all right, well, this is our ring, and there's going to be a slight little edge to it. Like this is point P, this is point Q. And there's going to be we're along the curve in that direction, right? And so what we're going to essentially want to do is figure out that width there. And that width is going to be the length, right? It's the length of our curve between P and Q. And so if we have a ring, right? If we have some sort of a ring like this, and we want the surface area of the outer part of the ring, we need the circumference, right? This would be the circumference here. We need that circumference, and then we need this width here. So we need circumference times, I don't know, width or depth or something like that, right? However deep it is, this, whatever this here, I'll call it W. We need circumference times that, correct? So if we go in to do this, we need to look at this and say, all right, we need, or times thickness. How about that? Thickness. All right. We need, for that area, we need circumference times thickness. And so to get our circumference, that's just going to be 2 pi times our radius, and then our thickness is whatever the thickness is, right? So 2 pi r thickness. Then we want to get our total area for the whole thing, so we're going to sum these all up from A to B, wherever we're going, 2 pi, and then we want our function, right? That's what our radius is going to be. This is r of x, correct? And so we'll put in our radius function, which is just our function, right? And then our thickness is not just dx here in this case, because if you think about it, if P and Q are like this, then the thickness is very different than if P and Q are like this, right? This would be dx. So here, the thickness may very well be equal to dx, right? But over here in this situation like this, they are definitely not the same. Our dx step is not the same as that. So we can't just have dx. We need to actually calculate that length. And that length there, as we found in last class, or not last class, but last week, it was 1 plus the derivative of our function, which I guess we're calling r of x, right? R prime of x squared, and then times dx. That is the actual length of it there. That's that thickness to it, that L. All right, which I guess I maybe should have put L up here times L. Okay, L equals thickness. Okay, L. Does that make sense? All right, so we're not doing, we're not just doing a dx there. We have to make that adjustment for, how steep it is, right? Because obviously if we're up here, it's pretty much going to be dx, but if we're way over here, this is dx, this is dx, and this is L. So they're not the same everywhere. Okay, so there you go. And so that's how we calculate the surface area revolving a thing around. You're essentially finding the length of it and then 2 pi r-ing it around in a circle. Okay. if you want to think of it that way. So here we go. First example, find the area of the surface generated by revolving the curve y equals 2 times the square root of x from 1 to 2 about the x-axis. So first off, limits of integration, what are they? Yeah, 1 to 2, right? So we'll go with our surface area. I probably should have put surface area. So surface area equals integral from 1 to 2. We need our 2 pi times our radius function, right? So this is going to be whatever this is. Oops, that wasn't a very, whatever this is here. It probably still should be at 2, right? This is R, which is essentially our output value, right? This is R of X, which is just F of X, which is just ultimately our Y value. So it's 2 square root of X, just like that, times our square root of 1 plus, and now we need the 2 square root of X derivative, right? So we need F prime of X. And so we have 2 times the square root of X. That's bring the 1/2 out front, right? So that's 2 times 1/2, which is 1. And then it becomes X to the negative 1/2, like that. And so this will just be X to the negative 1/2 squared, and then dx. Okay, and then it's just a matter of going through and do this. So we can bring a 4 pi out front, integral from 1 to 2. We're going to have a square root of X, and then inside of here we have square root of X, or yeah, the negative square root of X, 1 over the square root of X squared, right? That's what that is. So this is square root of 1 plus 1 over X, like that, because it was the square root of X squared, and then dx. And then we can go ahead and do 4 pi 1 to 2 square root of X. And then this one, we can give these both the same denominator. So this becomes X plus 1 over X dx. Right, I combine those. I made one X over X, and combined them into one fraction. Now I've got the square root of X in the denominator, and then I have that square root of X out front. So this is 4 pi integral 1 to 2 square root of X times square root of X plus 1 over square root of X, like that. That's what I mean, right? So that's going to cancel with that. And we've got 4 pi integral 1 to 2 square root of X plus 1 dx. And then how do I want to go about doing that integral? Yeah. So we can let u equal what? And then we can say du equals dx, right? And so this becomes 4 pi. Now, if I plug in 1 for x, I get u is 2. If I plug in 2, I get u is 3. And then I get square root of u du. And keep going. That's u to the 1/2 becomes u to the what? Over the 3/2, which is times the 2/3. Right? Then we can bring that 2/3 out front. This becomes 8 pi over 3. And then we just have u to the 3/2 evaluated from 2 to 3. And then this becomes 8 pi over 3 times 3 to the 3/2 minus 2 to the 3/2. So 3 cubed is 27, and then we have the square root of 27, right? And then we've got, so 8 pi over 3, and we've got the square root of 27, and then here, this is the square root of 8, right? I don't know, what do we want to do with this? We can make this 8 pi over 3. We can divide a 9 out of that 27 and give us 3 root 3. We can divide a 4 out of that and give us 2 root 2. Just like that. And I don't know, anything else we want to do there? Honestly, any one of those 3 places to me is a fine stopping place. Of course, if you had like a multiple choice, you'd have to know, you know, if you stopped at the first one, then you might have to know that that's the same thing as that last one, right? But really, I don't care. This one, or this one, to me are all equivalent. So, yeah. 743. I don't know. When is this test? When it's next week, right? Oh, give me time. I haven't even made it yet. I'll make it sometime this week. Y'all sure you want it next week? Because I mean, we're like done and after one more page here, and then that's a lot of. I guess it's just 2 days. I guess we could review tomorrow. You could have it Thursday. Seems like you're alone on that one. Sorry. Nobody's been keeping up with their homework like you, apparently. You're the only good one in here. Everybody else just let it slide, huh? Wow. All right. We've got this one here, which I'll leave for y'all to work on in a minute, not right this moment, because I want to go ahead and finish this just by talking about that right there. Here it is, swapped around to doing it if we're rotating it around the y-axis. So you're just changing it right to a function of y instead of a function of x, and the derivative of the function of y and over dy, right? Just invert the functions and invert what you're doing there, and it should work out, be the same idea. And there's an example of it right there below it. So example 2, which I have here. And then the very last one. So the only thing that's left is just find some of these. So I would, if I were you, I would start right here on this one. Why don't you all give this one a try? And you're going to end up with a cone there, and go ahead and try and solve that and see how you do. Okay. And then I can go over that one, and then you can try the next one if you finish with this one early. You should get 3 pi root 5. I believe that's what I got here. 3 pi times the square root of 5. So try for that one. This one was pi root 2, if you want to try that one next, if you finish that other one. So there you go. And then want to look at your questions here. All right. You gotta send me more than that. When you tell me what's your, just everything, I guess, I'm assuming with that. Okay. That's funny. All right. Y'all need this problem still up on the screen? Okay. Still in chapter 6, right? So this was 6.1.57. Number 20. All right. And then your other one was. All right, so let's take a look at this one. What do you think? So if you're looking at just this part, right? You obviously need to make this a function of y. Because you're rotating around in the y direction, right? You're doing x equals b, which I said was greater than a, which is my third on that column. All right. So to me, this is not a function in y. It's not a function in x, right? That's not a function. But the negative part is a function and the positive part is a function of y, right? Which is what I did. So I split them. And so I essentially did this one right here, which is the negative part all the way around, which gives me like a bulging disc kind of thing. And then I took this part right here and its volume rotated around, which would be the inner, like the whole part. Put it away, and that should include is the donut shape around the tube. Donut, right? And so this radius here is B, this, which is a positive, minus this negative, which gives me, minus a negative is gives me a good, a longer thing. And then this one is this minus this, which is minus a positive, gives me that short one. Right? Because one of them is with positive, one of them is with the, the minus the negative, and the other is just minus the positive. And then if you do those two integrals, which shouldn't be too hard, especially since they tell you what one of them is, a squared minus y squared, that integral, you just have that 2b constant out in front of it. It's just the area of a semicircle, right? And then the other ones are just integral of b squared, though that's just b squared y. A squared is a squared y, and y squared becomes, y cubed over 3. Should be able to do those integrals pretty easy. Plug them in from negative a to a, and then subtract the purple one from the blue one, the positive one from the. I think that should work. Assuming I didn't make any mistake in there, that should be the right idea. All right. And then, oh, I guess you can't see what I was doing here, huh? Because I've got it on the wrong thing. Yeah. Purple one from the blue one, but these should be pretty easy, doable. I've been recording this whole time.